Hi everyone, today's lesson is on solving quadratic trigonometric equations. And just a quick review before we start. So last class we actually looked at trig equations where the unknown variable was in trigonometric form, so sine, cosine, tan, etc. And this time we're going to look at the quadratic trig equations. So if last class we looked at trig variables being raised to the power of 1 or not raised to any power, this time we're going to see a power of 2 associated with those terms. So just a quick review about solving quadratic equations in general. First step first, okay, we need to take all terms to one side. Right? And obviously once we do that, we want to simplify. And we'll have anywhere from 1 to 3 terms in the left side. The right side will be just 0. And the second step would be solving it. And we know that when we solve quadratic equations in general, we can either go for the factoring technique, so we can use the factoring technique, or we can use the good old quadratic formula. Right? And I'm pretty sure you remember the quadratic formula, but I'm just going to write it here on the side. So the quadratic formula is x equals negative b plus minus square root b squared minus 4ac divided by 2a. So let's go ahead and move on to our first example. So the first example is sine squared x minus sine of x equals 2. So our variable in this case is sine of x. You can see this one is to the power of 1. And in here we have sine squared x. So that's what gives, this term gives the equation the quadratic nature, right? So I'm going to rewrite this equation slightly differently. So sine squared x can also be written, this term can also be written as sine x to the power of 2. The reason I want to do this is so that it looks more like a quadratic equation, okay? And then minus sine of x. And then I'm going to bring number 2 to the left side because I know I want to have all my terms to one side of the equation and have just 0 in the other side. And I'm going to attempt factoring first. And if that doesn't work, quadratic formula is always there for me. So here we go. Sine of x, sine of x. And now I need to find two numbers that multiply to negative 2 and to negative 2 and add to negative 1. So these two numbers will be the numbers negative 2 and positive 1. Doesn't matter in which order we put them in there. All right, it's supposed to work no matter what. And here we go. We have sine x minus 2, sine x plus 1 equals 0. So guess what? The next step, we're going to make each factor equal to 0. And we're going to write sine x minus 2 equals 0, or sine x plus 1 equals 0. We solve them as a linear equation, as linear equations. So sine x equals 2 or sine x equals negative 1. Now, I'll show you what my favorite equation is of these two. You probably guessed it. So this would be my favorite equation here. And the reason why is because I know that I cannot derive any solutions from sine x equals 2 because I know that sine cannot exceed 2. So sine has to be less than or equal to 1, okay? And obviously we remember that is bigger than or equal to -1. So this is what we call an extraneous root or solution. And that's where our work stops in here. That's where we have to stop in here. So sine of x equals -1 on the other hand. It's an equation we can solve. We're going to say x equals inverse sine -1. So let's take a look at our diagram. We're going to draw the angle that has a sine ratio of -1. And the angle with a sine ratio of -1, as you probably remember, is this one here. So 1 pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2. So that's the answer. We don't see any other angles in here that have the sign of -1 between 0 and 2 pi. So we are going to say that we're ready to state our solution, our only solution to this equation. So that's x equals 3 pi over 2, everyone. And I am going to circle this. Here we go. Okay, so that's the end of this solution here. All right, so again, if you would like to, you can pause the video and you can practice a couple of questions that are actually outlined at the very end of this handout. And I'm going to move on to the next example. So the next example requires a little bit more work. We are going to work on it together. 1 plus 2 sine x plus sine squared x equals cosine squared x. So one thing that we've mentioned in the past, we'll recall again, is that when we are solving an equation, we have to have the same variable throughout the equation. So here we have number 1. We're okay with 1. We have the term 2 sine x. And then we have sine squared x. So we have the same variable, sine of x, so far, right? Sine of x to the power of 2. So when you go to the right side, we see that we have a variable different than what we had in the left side of the equation. So guess what we're going to do? We are going to replace the cos squared x with something sine squared. And you've probably guessed already that we need to replace cos squared x using the Pythagorean identity. And I'm going to leave the left side for now as is. And cos squared x is 1 minus sine squared x. Remember the formula that we're using in here? The Pythagorean identity is sine squared x plus cos squared x equals 1. And that's where we get the cos squared equal to 1 minus sine squared. Okay, so moving on, we're going to take all the terms from the right side to the left side of the equation. So we have 1 plus 2 sine of x plus sine squared x minus 1 plus sine squared x equals 0. So we have a few terms here that stand out. We can combine them together. So we have sine squared x, and we have sine squared x in here as well. So we're going to combine these two together so that it gives 2 sine squared x. Now, as you notice in here, 1 and -1 simplify to 0. And then plus 2 sine x equals 0. So we have all the terms brought to one side of the equation, just 0 in the other side. And we have completely simplified the left side of the equation. There is one thing that we probably want to do. As you see here, there is a number that stands out, the coefficient before each term is the same. okay? You can eliminate this term, or we can eliminate this term by dividing both sides of the equation, every term in both sides of the equation, by that same number. And that's what we're going to do now. And we're going to see even a lovelier equation here. So we go 2 and 2 simplifies, and the left side becomes sine squared x plus sine x equals 0. So it's a quadratic equation, even simpler than the one in the previous example. So we're going to try factoring. We have a common factor here of sine of x, which we will take out. And then we have sine of x plus 1 in brackets equals 0. So we're going to take each factor, make it equal to 0. So sine x equals 0, we're going to say, or sine x plus 1 equals 0. So we need to do a little bit of work here, and sine x plus 1 equals 0. So let's simplify. Sine x equals -1. So we have two equations so far, 1, 2, and we're going to solve each of them. So x equals inverse sine 0. And we know that x equals, in this case, the sine will be 0. Remember, our domain is 0 to 2 pi. So the angle will be, the sine ratio will be 0 for the angle 0 radians, for the angle pi radians, and also for the angle 2 pi radians, okay? So 2 pi radians. So we derived 3 solutions from the first equation, and we got x equals 0 radians, or pi radians, or 2 pi radians. Okay, so I will highlight these answers. Okay, and we'll move on to the next equation. Sorry, I need to fix this. Sorry about that. This keeps coming, actually. I'm very sorry about it. Here we go. Okay, that's a little better. So, and then we're moving on now to the next equation. Sine x equals -1, x equals inverse sine -1. So let's take a look at where sine equals -1. So we just saw that in the previous example, so fresh memory of it, we have to look at the angle 270. You can simply use the calculator if you wish when it comes to evaluating or finding the values of the angle. And here we go, x equals 123 pi over 2. So it seems that we got quite a few solutions in this trig equation. So same thing is happening here for some reason. That's because it's the bottom of the page, I think, so I have to remember that. All right, so we got quite a few solutions in here. So 1, 2, 3, and 4 solutions. Okay, ready for one more? Moving on. Oops, move to the left. So now we're going to solve quadratic trig equations using identities, similar to what we just did. we have to solve this equation in the domain 0 to 2 pi. So there goes our domain. Always keep in mind. So we have 2 secant squared x minus 3 plus 10x equals 1. So you probably recall that secant is connected to tan, cotan is connected to cosecant. So I don't remember exactly the formula for secant. So what I'm going to do is write the Pythagorean identity that I remember very well. So that's the sine squared x plus cos squared x equals 1. And since I want to bring in secant, this equation, so I know secant is a reciprocal of cosine, which means that I must divide number 1 by cosine squared x. And I will divide the rest of the terms by cosine squared x. And that will bring us to sine squared over cos squared, that's tan squared x, plus 1 equals secant squared x. Again, you want to do this if and only if you do not, or you have not memorized the formula, right? So, and now at this point, we are going to work with our equation a bit. And obviously we want to replace secant squared. So secant squared can be replaced by 1 plus tan squared x, and then minus 3, and then plus 10x. That equals 0. Now we have the same variable throughout the equation. We're going to start simplifying the left side. So we have 2 multiplying 1 and 2 multiplying 10 squared. So that means we have 2 plus 2 10 squared x minus 3 plus 10x equals 0. So the first term should be the highest degree term. So that's 2 10 squared x plus 10 of x. And then we have plus 2 and minus 3, the constant terms. And what we're going to do is simplify, obviously. And 2 minus 3, that's negative 1, equals 0. So here goes our quadratic equation. So again, you can use a helping variable to replace 10 of x by a variable of your choice. I'm going to highlight them for now. So what we have in here, this is our variable, 10 of x. And here 10 of x is brought to the power of 2. And I'm going to rewrite it just for the fun of it in the form 2 10x squared plus 10x minus 1, okay, equals 0. So now we can see it a bit more clearly that what we are dealing with here. So we have 2 something squared plus that something minus 1 equals 0. So we're going to factor if possible. So we need to find 2 numbers that have a product of negative 2 and a sum of positive 1. So 2 and negative 1 should work. So I'm going to start factoring. Here go my factors, brackets. And I'm going to have 2 10x as the first term in one of the brackets and 10x in the other. So we don't have any other options in here. So it doesn't matter in which order we place them. So you can write 10x in here and 2 10x in here, or vice versa. And now I have to think of where to place the numbers 2 and negative 1. I want to have the sum of positive 1. So that suggests that I have a positive to a negative 1. Okay, so we have positive 1 in here and negative 1 in here. So we have 2 10x minus 1 10x. Okay, so that's 2 10x, take away negative 10x. Minus 10x. So we're going to solve each equation. So 2 10x minus 1 equals 0, or 10x plus 1 equals 0. So 10x equals 1/2, or 10x equals negative 1. So x equals inverse 10 1/2, or x equals inverse 10 negative 1. Okay, so I'm going to start with the first equation here. All right, so you probably recognize 1/2 as a special ratio, but remember, it's not associated with tan, it's associated with sine and cosine. So in this case, we are going to have to use the calculator. And by the way, I found this cool calculator online, and it was a free download. So there we go. I'm going to use that. So we have to use, I'm not going to rate you right now, and you have to go away. And I don't know it's very hard to get. That's what happens with free stuff. Okay, so I'm going to have to find I'm going to have to set the calculator in radian mode, and my angles are here in radians, okay, as you can see. So I'm happy with that, and I can go ahead and calculate. So I'm going to go second 10, and then in brackets, automatic. So I can either write 1/2 or 0.5, but let's write 0.5, why not? I know how to divide 1 by 2. So I go 0.46 in here. So let's go back to our lesson. So we're going to say that 0.6 is the value of x. Sorry, it was 0.46. So eraser, I made a mistake, 0.46. Okay, remember to round the radians to 2 decimal places for reasons that we mentioned in the first lesson. So always radians to 2 decimals. And I'm going to go ahead and draw the angle 0.46. Now, how do I draw that? It's just sketching, if you remember. And remember that 1 radian is about 60 degrees. So it's about this big. So 0.46 is less than half. And we are going to go, let's say, like 28, 27 degrees. So I'm going to sketch the angle right here. So this would be the first angle. And since we're using 10, the second angle will be found by extending this line towards the opposite quadrant. And I'm going to show my angles right here. Let's go green. So this is one, and this is another one. So we can see here that if the first angle is 0.46 radians, so the next angle will be 3.14 plus 0.46. So, and that would equal, let me do that. So 0.46 is about 3.6 radians. So far we got 2 solutions, and now we're moving on to the next equation. So let's highlight this solution to start with, and we're going to go green for this answer. And there goes the first set of answers for this equation. Okay, so we are going to solve the next equation, And we know that 10 will be -1 in quadrants 2 and 4, right? And that will happen for the angles. I'm going to go pink this time. So that will happen for the angles 135 and degrees. And here we go. And let me show where the angles are here. So we have one angle here with 10 of -1. And there goes the second angle. So again, let's count how many radians it is. So we know that in one quadrant we have a pi over 4, 2 pi over 4, 3 pi over 4. So we have 3 pi over 4 right here. And the next solution is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. And if you were thinking that, oh, we could have gone 2 pi, take away pi over 4, so same thing, you are most definitely right. Okay, so I'm going to list the next solution. So we said x equals 7 pi over 4. All right, so here we go. We got 4 solutions to this equation. Moving on to our last example, we have 3 sine x plus 3 cos 2x equals 2. And as you see here, if you take a look at the variables, so what we have is sine of x as one of the variables, and the other variable is cosine 2x, definitely not like variables. So we want to make them alike, so we have to think, can we change sine of x into something cosine? So we're going to say, well, if it was to the power of 2, maybe, but it's power of 1, so maybe we should look at other options we might have. So now we take a look at cosine of 2x. So for cosine of 2x, if you remember, we had quite a few formulas that we learned about double angles. So we said cosine 2x equals that formula that looks like Pythagorean identity, but it's not the Pythagorean identity because it has a minus between the terms. And then we said we had cosine 2x as 2 cosine squared x minus 1, or cosine 2x as 1 minus 2 sine squared x. And you remember how we talked about it, and we said we can derive the formulas, last 2 formulas, just by replacing either cosine squared or sine squared by the respective values or expressions. According to Pythagorean identity, sine squared plus cos squared equals 1. Okay, so which one would be our formula to use in this case? So we're going to say, well, if you look at these 3 formulas and our equation combined, then we're going to say that we're going to need to bring sine squared in. So what that means is that we're going to go for the last formula in here. Okay, and let me make this a little bit fancier. And we're going to replace cos 2x. So let's get to work. So here we go. We have 3 sine of x plus 3. Instead of cos 2x, we said we're going to write 1 minus 2 sine squared x. And that equals 2. So we're happy we have sine squared and sine throughout the equation and some numbers. We're okay with numbers. We're just simplifying now. So 3 sine x plus 3 minus 6 sine squared x. And why not bring 2 to the left side since we're here? Because we know we are dealing with a quadratic equation. And we're going to reorder the terms. So the first term would be the sine squared term. Okay, and here we go. Negative 6 sine squared x. Then the next term would be the sine of x term. So plus 3 sine x. And we have 3 and negative 2 that will make a positive 1 together. Now, we have to solve this equation, but we don't want to have a negative coefficient, leading coefficient. It's better to replace it with something positive. And since we are in an equation, we have the luxury of doing it because we can do same thing to both sides of the equation and nothing will change in it. So we are going to divide every term in the equation by a negative 1. Now, it's not an operation that you can show the way I am right now. You can simply rewrite the next step as 6 sine squared x minus 3 sine x minus 1 equals 0. So we want to factor this equation, and I am thinking if I want to factor, I need to know or find two numbers that will have a product of negative 6. So how do I know that? Well, I want the product, right, to equal negative 6. 6 times negative 1. And in the meantime, I want the sum of these two numbers to be negative 3. And the reason why I'm saying the sum has to be negative 3 is because we have a negative 3 right here. Okay, so can you think of two numbers that multiply to negative 6 and add to negative 3? And remember that we can only play with integers. So I'm going to look into them. So 3 and 2, no. 2 and 3, no. 6 and 1, no. So what that means is that our only resort here would be the only way to solve this would be the quadratic formula, because these two numbers, I mean the numbers that multiply negative 6 and add negative 3 don't exist, so it's not factorable. But remember that if an equation is not factorable, doesn't mean that it's not solvable. So here we go. We're going to use the quadratic formula. And feel free to use a helping variable. I am going to continue with sine of x, no helping variable, equals. Now, if you want to, I think it can be helpful to identify your coefficients. So we have A positive 6, B negative 3, and C negative 1. So long line, and negative b plus minus square root b squared minus 4ac over 2a. So sine x equals negative b means negative 3 plus minus square root of negative 3 squared minus 4 times 6 times negative 1, everything over 2 times 6. I'm curious to see what this difference would be. So negative 3, positive 3, plus or minus. So here we have 9 plus 24, and 9 plus 24, root 33 here, divided by 12. Okay, definitely not a special ratio or a special angle. So guess what? We are going to separate the roots for now. Let's say sine of x equals 3 plus root 33 over 12. or sine of x equals 3 minus root 33 over 12. All right, and x would equal inverse sine 3 plus root 33 over 12, or x equals inverse sine 3 minus root 33 over 12. So let's search our answers. So we're going to use the calculator for this, and I'm going to use a calculator that I have uploaded on my tablet, just so that I can go over the operations and a few other things I want to mention that I think are important. So number one thing is that I would prefer that we keep this expression in exact form. So what that means is that when I'm trying to find the angle x using the calculator, I'm going to type in the whole expression. Now, we have to be careful, though, when we have expressions of in fraction form. So we need to keep the numerator in brackets and then divide it by the denominator. So I'll walk you through it while I use the calculator. So again, we said that we have to find the angle using the sine ratio. And we have 3 plus root 33 over 12. So second sine, and see how the brackets in here open. And I am going to open another set of brackets for 3 plus, and then we have the square root of 33. The square root of 33 here is right here under, so second, so root 33. I'll close this bracket. Okay, I didn't need this one actually, so I will just delete this. Interesting. Okay, so okay, I'm gonna clear this. So second sine, 3 plus square root of 33. Okay, I'm gonna get out of here and then close my brackets. Close the brackets again. Divided by, we said 12. So now I close the big bracket. So you have 2 brackets on the sides, and then your numerator will be in brackets as well. So the 2 brackets on the outside ensure that everything is inside the sine as an angle. So this represents as a ratio. And we are not making any miscalculations or messing up with bad math. Okay, so let's take a look. 0.82. So 0.82 is our first solution. So we're going to say x equals 0.82. And the next solution will come from the second equation. So we're going to go back to our calculator, and we're going to go second sine again, brackets, and then 3 this time minus the root of 33. And I'll remember here to go out of the square root, and then divide that by 12, close the big brackets, and I got negative 0.23. Quite interesting. Okay, so we're going to say x equals negative 0.23. So a little bit of work we have to do in here, quite a bit actually. So this is the solution. 0.82 is the solution that would derive from sine of x equals 3 plus root 33. So that's the one. Okay, and while we're here, we're going to draw this angle on the Cartesian plane as indicated. And we're going to say that 0.82 radians is almost a radian, so I'm just going to estimate somewhere in here. Again, it's just a sketch. And the angle, the other angle with the same sine ratio will be this angle, or this terminal arm, reflected around the y-axis. So I will draw that. Okay, so just sort of an estimation again. Oops, I don't think I like this very much. So let me go this way. All right. And I'm going to indicate where my angles are right now. So we have one angle here and one here. These are the two solutions we get from the first equation. So 0.82 radians. And the other one would be 3.14. Take away that 0.82, right? And 3.14 take away 0.82 would equal 2.32. So I'm going to state both solutions in here. So x equals 2.32 radians. So two solutions that we got from this equation. Now we're going to explore the solutions from the next equation. So let's go green. I like green. And from this equation here, I wanted to do this actually. From this equation here, we got the solution. All right. Now, obviously, this is not in the domain. All right. So not part of our solution, but we still need this angle. We're still going to draw the measurement of this angle right on the Cartesian plane. Negative 0.23 will be an angle in the fourth quadrant. Okay, so that's where negative 0.23 is. It is true we don't need this angle, or we won't list it as a solution, but this will lead us to the answer. Now remember that there is normally two angles that share the same sine ratio, and this will represent the terminal arm of the first angle that has the sine ratio as given in here. And we are going to use this terminal arm to figure out the next angle, so the second angle. And to do this, we simply reflect this terminal arm about the y-axis. Why? Because we've used a sine ratio. And if you reflect it about the y-axis, then you will get something like this. And we're going to say we got the two terminal arms that have the sine ratio of 3 minus root 33 over 12. So let's do some very simple calculations to figure out what these angles are. And I'm going to use a dark green here. So if this is 0.23, then we're going to read the angles, the solutions that are part of the domain this way around. So that means that we're going to have this bigger angle here, 2 pi minus 0.23. And if you use a calculator, then 2 pi minus 0.23 will give 6.05 radians. So the first solution will be 6.05 radians. The other solution will be this one here. Okay, so this angle here would be pi radians plus 0.23. And pi radians plus 0.23 would equal 3.37 radians. So the solutions we derive from this equation then will be x equals 3.37 radians and x equals 6.05 radians. So let me highlight them. These are the solutions that we got from the... I actually didn't mean to do this. I want to use a different color, but that doesn't really matter now, I guess. All right, so these two are the solutions. And what we're going to do is make one final statement and saying that, okay, this is not a solution. But it was great help because this angle helped us find the correct solutions in the domain given. Okay, so you have a few questions in here that you can practice. So right after we finish the lesson, or you finish listening to this lesson, I would like you to please practice question number 1B. So that's number 1B. Question number 4B. So here goes number 4B. Question number 6. Okay, and then question number 8. And then you still have another worksheet that I am posting online. So please complete the questions as indicated there. I would suggest that you do every other question. I gave you more details in our Google Class posting. All right, so I hope you learned from this lesson. Please follow the examples, pause when necessary. Make sure you print out a blank copy before you start listening to the video. It's important that you listen actively. That will ensure better learning and quicker learning in the meantime. Do the practice questions, and the next day post all the questions that you might have. So